Here we have a SAT math problem. Okay, let's go to the question. In the figure above, an altitude of a right triangle from the right angle splits the hypotenuse into two segments of lengths AD and DC. Which of the following is closest to the value of AD? Okay, in the given figure, we have to find the length of this line segment AD. Okay, so it is known that the triangle ABC over here is a right triangle and this AC is hypotenuse because it is opposite to the right angle. Okay, using the lengths of the two legs AB and BC, we can get the length of the hypotenuse AC by Pythagorean theorem. Okay, according to Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of other two legs, that is AB square positive BC square. Okay, here for AC, I do not know the length. We have to keep this one as it is. For AB, I know the length 16, so we can plug in 16 for AB, that is 16 square. And for BC, we have the length that is 30. We can plug in 30 for BC, then we get 30 square. Okay, then AC square equals to the value of 16 square is 256 and the value of 30 square is 900. Okay, AC square equals to, when we add them, we get 1156. Now to get the exponent 2 over here, we have to take square root on both sides of this equation. When I take square root on both sides, the square root and square will cancel out. And when we take square root on both sides of an equation, for this square root, usually we consider positive or negative sign. But here, AC represents the length of one of the sides of the triangle. It cannot be negative, so we don't have to consider positive or negative sign over here. We can consider only positive sign for this one. Okay, here we get AC on the left side. The square root of 1156 is 34. Okay, here I got the length of AC, that is 34. Okay, now let's consider the angle measure over here. Here we have a right angle. So on this side also we have a right angle. Now we can consider two right triangles. One is the smaller right triangle ABD over here, and the other one is the bigger right triangle ABC over here. Okay, now let's consider the vertex A. So this is a common vertex for both the smaller right triangle ABD and the bigger right triangle ABC. Okay, here the two interior angles of this smaller right triangle are equal to the two interior angles of the bigger right triangle. By angle similarity postulate, the two triangles are similar. Okay, now let me take the vertices of the smaller right triangle first, particularly the vertex A. Okay, now let me write the similarity statement. That is, I'm taking vertex A in the smaller right triangle. What is the corresponding vertex in the bigger right triangle? So that is also A, because A is a common vertex. And now let me consider the vertex D in the smaller right triangle. What is the corresponding vertex in the bigger right triangle? That is B, because at D we have right angle, here at B we have right angle. Okay, the third vertex in the smaller right triangle is B, and the third vertex in the bigger right triangle is C. So these two triangles are similar. By angle similarity postulate. Okay, now let me write the ratios of the corresponding sides. Let me take the side AD in the smaller right triangle. To get the corresponding side for AD, we have to consider the letters at the same position, that is AB. Okay, now let me take the side DB. Okay, the corresponding side is BC. Okay, let me take the side AB, and the corresponding side over here is AC. Since these two triangles are similar, then the ratios of the corresponding sides must be equal. That is, the corresponding sides are proportional, so we can equate them. Okay, here all the three ratios are equal. So since all of them are equal, we can equate the first one and third one. Then I'm getting AD over AB equals to AB over AC. Now we have to solve for AD in this equation. For that, we have to plug in values for this AB over here, and AC over here. Okay, AD divided by the value of AB, that is the length of AB is 16. We can plug in 16 for AB over here and here. Then I'm getting 16 over here, 16 over here. And the length of AC is 34. We can plug in 34 for AC over here. Let me multiply both sides of this equation by 16. When I do so, this 16 will cancel out. Then I'm getting AD on the left side. 16 times 16 is 256 divided by 34. Okay, here when I divide this 256 by 34, I am getting 7.529, and it keeps going. It's a long decimal. Okay, here I got the length of AD. Now, when I go over the answer choices, the one which is very closest to this value, 7.529, is the value 7.5 in answer choice A. So, among the given answer choices, the value which is closest to the length of AD is 7.5. So, the correct answer choice for this question is A.